We're Group 18. I'm Luke Gaskill.
I'm Ryan Stolley.
And I'm Clark McNally.
And this is the Smart Lock. Alright, so basically what this is, the Smart Lock is it's supposed to be a residential door lock system which enables the user to lock and unlock their door via Wi-Fi through their smartphone, or lock and unlock it using a registered RFID tag. And so my
responsibilities were the mechanical construction, dealing with the RFID scanner, and the servo motor to turn the lock. So for the assembly, so we got a huge box from Radio Shack, and under that box we had our Wi-Fi shield and our Arduino board and our batteries, and then underneath this smaller box that we got from the engineering hardware store is our RFID. It's screwed in from this side in because we didn't want anybody ripping it out. I got help from the mechanical shop to go and configure the box because I didn't have the tools to go do that. Inside here, of course, is just a basic lock I got from Lowe's. Let's go to the next one. So the RFID reader that we got is an ID12LA. RFID, if you don't know what that means, stands for radio frequency identification. Basically every single building on campus uses an RFID, so we wanted to add it to our project as an additional way to automatically unlock your door. We were going to use our student IDs, but the frequency was different, so we actually had to go buy a different card. And basically all you do is just take your card and just swipe it against the RFID box. So the servo motor we have is a high-tech SH3022HD. Swivels 180 degrees. We only needed to go swivel 90 degrees to go turn the lock on and off. Basically, that's we have a different gearbox than that on there, more of just a straighter one, and it's drilled into the deadbolt part of the lock. We would have done something a little bit different later on, but we didn't have that much time.
And my responsibilities for the project were the Android application, the Wi-Fi connection, and the security. So the Android application's core responsibilities were it has a certain amount of door functions where it would allow the user to lock and unlock the door, enable and disable the RFID reader, and enable and disable the RFID discoverable mode, which is the approach we decided to take to register new RFID tags with the system. And the user management functions for the Android application are it allows users to register a new account with the app and update their user password and update the device IP address and the device ID. And I'll get to the device ID here in just a second. So this is kind of the general look and feel of the Android application. We have just a general registration page where they can register with our app services portal, and which manages our users, and just a general login page, and the main page, which is where the user can lock and unlock the door from here. They can refresh the Wi-Fi connection to the system, and they can go into the settings page, which here they can go in with the RFID settings. They can configure the RFID scanner. They can go in and configure the connection settings, so the IP address and the device ID, and they can change the password. And so Apogee App Services is the user management portal that we decided to use. It's just a simple kind of free open website called apogee.com, and it allowed us to manage users on the app and in the database. So it allows us to create and store users both on the app and straight to the database. It allows us to authenticate users on the app and to update their information. It also allows us to set roles and permissions. So if we wanted, so we can have administrator permissions and guest permissions for the app. And it also allowed us to monitor data storage and track active sessions and user information and user data. And it's also like a convenient tool because it reports crashes directly to the developers, us. So it's a very helpful tool. And so because it's this device is almost a rudimentary home security system, It was a paramount problem for us to kind of solve. So the approach we took is we just have a user credentials, and through FG App Services, they actually encrypt the password, so not even system administrators can see the password itself, and there are certain constraints to the password that the user enters in. And we also used a 128-bit device ID code, which is kind of which handles most of the security. So each device is then hard-coded with a unique 16-character alphanumeric device ID key. And what this key is used for is the user has to enter this key into their app, which then registers it with their specific device. And then every command sent from their device has the device ID key attached to it. And the device will only issue commands and execute them if the valid ID is included in the message. And the connection we used to our system was a just simple TCP connection, so the connection remained open once they have the main view open, and this would allow us to constrain the device to have an open connection with only one user at a time, which is kind of another level of security in itself. And the connection is open throughout while the app is open, so they're not trying to connect and reconnect all the time, and they're not getting as many lost packets in process. And here's just a simple example of a command that we might set. It has a command code, so I guess the code for 2 was locked for us, and then here's the device ID key that gets sent along with it.
So my responsibilities for this project were the hardware selection, the Arduino server, and the iOS application. For the microcontroller that we decided to use was the Arduino Uno. It's a very simple thing to use, and it also allows to add on the Wi-Fi shield. So we chose to use the Wi-Fi shield because part of it was that you didn't want to run an Ethernet cord all the way around your house to your front door. That's just not logical, so we decided to go with Wi-Fi and use batteries to power it. And then we chose the high-tech servo motor because it had enough torque to turn the deadbolt. And then like Ryan said earlier, we used the ID12 RFID reader. So one of the big things we had to do was use an Arduino server. So the server was responsible for handling all the incoming connections. Like Luke showed, we sent a simple command of a 1 or a 2. The Arduino server handled the 1 or the 2 command and then decided to unlock or lock the door. It was also constantly updating the status of the door. So we had a website where it would parse the JSON, and it was a door state was either 0 or a 1. And this allowed for the mobile applications to read that JSON in and then update the door to say either unlocked or locked. Some of the challenges we had with this server was that the Wi-Fi shield isn't the most robust thing. It only allowed for one TCP connection to be open at a time. So when my app was open and Luke's was, only one of us was allowed to connect at once. So I guess in the future we'd probably choose a more robust wireless system. So the iOS application, the exact same core functionality as the Android app. One of the big difficult things we had was that iOS and Android don't really go together very well. It's not easy to translate both languages. So we had to work on, getting, both of us had to figure the TCP connection out. But, the buttons don't look the exact same. So that was one of the big things. And then I had previously never learned iOS, so that was a cool learning curve to figure out how to program that. So this is the look and the feel of the iOS app. Similar registration page to the Android, similar login page. And then, the buttons look a little bit different, but it's very much the same. So one of the things you were able to do is hit this update button, and you would see a progress wheel spin. And then this last updated label would say, last updated April 30th, 1:30 p.m. So you always knew what time you last updated. And then there's the settings page.
So for future plans, like Clark said earlier, a better Wi-Fi shield. I mean, that was one big struggle for this project. Another thing, minimize the size of the mechanical design because it's really bulky. Probably instead of attaching the servo to the deadbolt itself, probably some kind of key hex thing or something that goes inside the lock.
One of the other things we could have considered for that as well was using an electromechanical lock where you would, apply 12 volts and that would change the deadbolt. But most residential systems use a non-electronic lock.
Yeah. And then another thing, enable push notifications. So if Luke updates or unlocks the door, Clark would know. Otherwise, right now, of course, they don't know. That would have been nice. And then maybe add a porch light feature to it. That was one of the things that we wanted to add at the beginning, but I mean, it was coming too much, so we just stuck with just the lock itself. So for acknowledgements, we'd like to thank the Mechanical Engineering Lab. They helped with the tools for the assembly part, for the cutting and the drilling of the project box. I borrowed a power tool from my dad who works for the Army Corps of Engineers to do to put the deadbolt on the door, and then Professor James Kramer for helping with the iOS app help.
Questions?